Okay, you ready?
Yep.
Okay, let me cue this up here real quick.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Al Williams.
This is episode 335, Beer, Toast, and Pie. This week in science news, confirmation of a record 220 PeV, that's peta-electron volt, neutrino. This was the neutrino event detected back in 2023, February of 2023, 2 and a bit years ago. They've been crunching the numbers ever since. Neutrinos kind of pass through everything, and so you need one of these awesome neutrino detectors to find them. Oh man, Lewin wrote this awesome article on neutrino detectors. Why is that not linked in this one? Boo. Basically, to make a neutrino detector, you get a ton of some fluid and a whole bunch of photomultiplier tubes, and you look at it and you wait and you wait and you wait for a flash. And because neutrinos don't like to interact with matter particularly at all, you just get a huge bulk of something transparent and look at it. And that's what they did here. And this is the highest energy neutrino ever detected. Hooray, weird science. I loved Maya's conclusion on this one that, we had no idea that there were neutrinos that were this energetic. And she's like, well, we didn't have neutrino detectors everywhere until recently. So how would we have?
Yeah, Lewin tried to explain neutrinos to me once, but it went right through me, so I don't know.
Awesome. I'm going to fetch Lewin's article and throw that straight in the show notes because that's actually a favorite of mine.
Yeah.
Neutrino detectors are kind of so incredibly, they're huge scale, but they're very low tech. And I love that about them.
Are you going to link to the Avi Loeb press release saying that this is obviously a signature from an alien warp drive?
I wasn't aware that it was, but no, I will not link to that.
I'm not aware of it either, but I'm sure it's there, right? I'm just judging by, common sense.
In Hackaday news, last week the 1 Hertz contest ended, and I said we were going to get judging it. I didn't realize at the time we had like 140 entries. Our judges are still working on it. We'll get the results to you next week. Sorry about that, but man, what a great turnout for that contest.
Does that tell us that was too easy, that we need to have like the picosecond challenge or?
Yeah, ooh, that's good. Man, every time we talk challenges, you come up with another good one. I'm writing these down.
This is a journey into sound.
What's that sound?
What's that sound?
Then that brings us to What's That Sound? Let me go upload the file for you. In case you don't know, What's That Sound is a contest where we play a sound, Al guesses what it is, and you can guess along if you get it right. Next week, we'll draw among the right answers for a chance at winning a Hackaday podcast t-shirt.
Oh, you're giving me a softball, Elliot.
Is it? All right. What you got?
That's the... And weirdly enough, just last night, I was watching, I think, Black Mirror, and that something really similar to that was playing, and I was thinking, oh, they ripped that off from totally.
Nice.
So,
Nice.
Perfect timing. What a low ball.
I'm pleased to give you a low ball every once in a while. It's good. We'll see if our listeners know. If you out there have an idea what this is, head on over to hackaday.com/podcast. Fill out the form with your best guess, and next week we will pick among the right answers for a chance to win a Hackaday podcast t-shirt. All right, my first hack this week comes from Fieldman. This is automated brewing. It's a fantastic, automated brewery device, but on a home stovetop scale. I love the comments on this one. Invisible Man comes in. He's like, I hate beer, but I really admire this setup. And that's what really drew me to this one. Although I used to brew beer a ton in grad school. The stage of beer brewing that's the most onerous is mashing the beer. And that's where you take the malted barley and you soak it in water, but it has to be at a very precise temperature for the enzymes to convert things into sugars that then can be eaten by the yeasts later. And there's all sorts of flavor profile stuff going on here. And so professional breweries do kind of a 3 to 4 hour mash where they're holding the barley in the water at either a single precise temperature or stepped temperatures. Anyway, super annoying to do if you're a home beer brewer. And that's the part of this that he automates in the most interesting way, anyway. He makes basically a stirrer machine and temperature sensor built into the lid of a pot. So he can just put it on a normal pot of his. And then he gets a standalone induction stovetop plate that goes underneath it and controls, adds the heat to control the temperature. Wow, there's tons of great detail in this build, from the way he went around making the stirrer and all of that. It's just, your kind of basic home automation, your basic home factory automation project. Controlling the heat of the hot plate, which was a $30 model he got from IKEA, is the coolest part of this. I guess a number of the commenters pointed this out. It's also another Hackaday IO projects of Fieldman's. DIY PWM controlled IKEA Tilreda induction cooktop. You should absolutely check that one out. It's really cool because the heat part of a heat control system, like if you want to make like a sous vide, or, if you're Dan Maloney, some kind of bioreactor, I don't know what you're into. If you want to control the heat, usually it's like built into the vessel. And what I love about this is he could just take any pot off his stove, put it on this thing, combined with the temperature probe and the PWM controller. It gives him temperature control in an arbitrary pot of his discretion. Hacking the IKEA stove to get it under his control is actually the really cool part. He gets in between the control front panel and the actual power boards that make the stove get hot. Figures out a serial communication protocol that the two of them have, and is able to put an Arduino in the middle of it, giving him complete control of this induction cooktop, which is, I think, a fantastically useful hack, aside from the whole brewery aspect here.
I think what I thought was really interesting about this, and it's not the first time it's crossed my mind, beer's been being produced for at least 3,900 years, and some say 5,000 years. And I'm guessing they didn't have any sort of high tech. That would actually be an interesting article, maybe not for Hackaday, but maybe as, how did you brew beer 3,000 years ago? I don't know the answer, but I will tell you where I went to college, or one of the places I went to college, they had a department of enology. And one of my friends, who's a ham radio operator, was majoring in enology, which is winemaking. He took me on a tour of where they did the wine stuff, and it was very low tech.
Yeah.
It was, I think they had a hygrometer. That was probably the most high tech thing in the whole place. But they had machines for like filling up the bottles and stuff that all worked on gravity and liquid levels and, no valves and solenoids and level detectors, nothing like that, just purely common sense. So I'm kind of surprised that, I'm sure this does better, right? For something to find better, tastes better, less waste, less likely to ruin the batch, something. But man, people have been doing this for a lot longer than we've had anything even remotely like this. So I wonder what you're the beer brewer. What are the benefits compared to doing this the way the brewer of Mesopotamia would have done 3,000 years ago?
Yeah, right. Well, the joke about wine and beer is that wine, of course, is made in the vineyard. Like if you have good grapes and you don't screw up, you'll get good wine out of it. Whereas beer is like an engineering product. You just take straight up regular old barley and you do the rest. I guess what yeast you get is very crucial. But like if you go into a modern beer brewery, they use a lot of the tech that Fieldman's using here. So it's funny. Beer is really like an engineering product. It's like food science rather than wine, which is just, you pitch some yeast in it. And if the grapes were good, the wine is good. But for as much as this is a really awesome and refined project, there's still some room to improve things. At the end of the mashing phase, you want to cool it down, and you want to cool it down pretty quickly. And right now he's doing that by just taking some cold water, putting it in another dish, and then just sitting in it like kind of an inverse bain-marie or something. He could throw ice packs in there for all I care. It's that kind of low tech, and a bunch of people in the comments were like, he hasn't gone fully overkill yet. There's more overkill left to be extracted from this project. If you're at all interested in kind of home automation, especially home cooking automation of this kind of like mini factory style, you should absolutely go check out his IO blog. It has a good discussion of like the trial and error about building the stir apparatus. And he started off with a stepper and a bunch of 3D printed gears, and then went to a cordless drill motor, and then finally ended up just kind of sourcing. Looks like a car windshield wiper motor. It's a big DC motor with a gearbox, but it runs on 24 volts, so I don't think it's from a car. Anyway, whatever. Really cool stuff. Just a great all-around project, and totally agree with Invisible Man. Even if you're not into beer, you'll like this.
Well, I guess we'll go from beer to toast. My pick this week was Vin the Wrench, and the article is How to Stop Zeus from Toasting Your Pie. Well, I could have said we went from beer to pie. I guess that works too. So this is sort of an interesting story. Vin apparently lives in rural Arkansas where they're subject to really massive lightning storms. I don't know if he knew this or discovered it, but lightning's only part of your problem. The lightning affects the grid and they do switching and stuff. So you get these giant transients when they switch, the entire network over on your power lines. And, all the consumer stuff for this is almost a joke. If you've ever worked with lightning prevention, oh, you get a surge protector. Yes, a surge protector. And it's got a 600 joule MOV in it. Well, that's nothing. And what's worse is, and some people don't know this, is that the MOVs actually degrade over time because every time they absorb a surge, they get a little less. Basically, they're a wear item. So if you really want to do that right, you've got to open them up every 6 months and replace all the MOVs in them, which of course nobody does. So I guess he went in and decided to build the Zeus Filter 1.0. And it's a, classically over-engineered system, but it really depends a lot on the gas discharge tubes, which if you're a ham radio operator, you've probably seen those for protecting, if you've got an antenna up over something, that's a very common way to do that. So gas is a pretty good insulator until it isn't, right? So you pick the right gas. When you get a certain level of voltage on the wire, it becomes a super good conductor and you shunt it off to a heavy ground. But he's also got big MOVs, common mode chokes, just, safety caps to bleed off anything that's left. And of course, like I say, the big grounding. I think that was just interesting because that's something you don't think about a lot. I talk a lot about we abstract everything. So our wires are perfect and our transistors all drop 0.6 volts across the base emitter junction, our bipolar transistors, et cetera, et cetera. But the real world is much uglier and messier than that. And lightning and AC line transients are certainly part of that messy world that most of us don't think about very much. If you look at how they do lightning protection around, say, anything tall like a rocket tower or a oil rig or anything like that, it's not just a guess. They've got a lot of things that they do to make sure that the lightning doesn't go on the expensive piece of hardware. It goes somewhere else. And some of those things are the same things that Vin works on here with the Zeus filter. So I don't know. Are you building a Zeus filter, Elliot?
Absolutely not, but I love the title. I like the idea of actually defending yourself against a Greek god. I think that's it's brave for an electronics project, but I like to see that. The writing here is absolutely hilarious. This is written up by Heidi Ulrich, and it's just a fun read. You should definitely check it out. And also head down into the comments where a bunch of people provide some constructive criticism. Vin the Wrench is in here talking with them back and forthing. Some people have had experience in industries with lightning, industries that are subject to lightning. So there's a good crowd here. Good constructive suggestions from the Hackaday commenteers, and Vinny's in there paying attention. So I'm sure version 1.1 of this board is going to be even better.
Assuming Zeus doesn't strike him down first, right? So smite him for his arrogance, yes.
The Greek gods had a thing about hubris, didn't they?
They did.
My next one, battery repair by reverse engineering, is a fantastic look into basically an eBay haul of dead Ryobi 18-volt lithium-ion battery packs. And I know a bunch of people in our community have been reusing power tool battery packs for their projects because, they're a convenient form factor. You have the chargers on hand, they're easy to get. What's really neat about this one is that Ryobi 18-volt ones apparently have a couple failure modes that put the battery packs up on eBay, but most of these failure modes are easily recoverable if you know what to do. And Badar here tackled the really big one. He has this marvelous chart in his write-up of, what the cause of the battery pack not working was. And a full 65% of the time, the problem was this, quote, permanent firmware lockup. That's what he's doing here mostly, is digging into that cause, because that's the one that hadn't been solved yet. Other things that can happen to them is if the cells get badly out of balance, there's a jumper you can short and reset it so you can, rebalance the cells and then do that. You're back to the races. That's about 20% of the time. And then kind of the other 20% of the time is things you probably don't want to try to fix the pack anyway, like the cells have been deeply discharged or whatever. That's just, you should probably throw that pack away. But that leaves the 65% chunk, the big chunk with this permanent firmware lockout. And it looks like Ryobi has some code in the microcontroller's firmware that when it sees a situation that's bad enough, it actually flips a bit and it never powers on again, only to give you a blinking, flashing error code. And the way Badar figured this out is he had a good one and a bad one, and he actually dumped the binaries off of both of them and compared them. And lo and behold, there was a 1-bit difference between the two. And you can just go in, flip the bit, reflash it to the microcontroller, and it works again. So fantastic hack to fix these things. This is 65% of his sample of failures had this problem with it. So it's a huge problem with these batteries. And now fixing them is as easy as getting in there with a SWD programmer. It's neat. It uses Tag Connect. So if you have a Tag Connect header already, you can just go in there, SWD it, and you are off to the races again, saving the batteries from the landfill, et cetera, et cetera. The other thing that's really cool about this is that along the way, he essentially completely reverse engineered the LiPo charging and power infrastructure here. And it's actually kind of a cool look into what a commercial power control circuit and charging circuit like this looks like.
I noticed the comments started out exactly what I was thinking is, so is this where you go, wow, this pack's really dangerous, it might explode, I better disable myself rather than take a risk? Or is it, hey, you've used this battery enough, I think you need to buy another one? We're not making any money off of you, so I don't know. It's kind of interesting to never blame for malice what you can explain through incompetence. So maybe it's not malice, but certainly my mind went there.
Badar actually raises that question in his write-up, and he says, most of these batteries have a 3-year warranty on them. And in fact, if they get bricked like this, you can just send them back and they'll send you a new one. Presumably, they then look at it in the factory, determine if the cells are okay, and then reflash it and sell it to somebody as a used battery or something. I don't know what. But, if they've got a 3-year warranty, but who knows, maybe the bit's set to flip after 3 years.
Yeah, I mean, there's any number of although you'd wonder how it keeps its time. But, it's interesting, though, if you think about how the business works, right? I wonder what any company like Ryobi or any of these companies, they're basically selling these little bombs. What does their liability insurance look like, right? What do when you go say, hey, I'm going to make, highly flammable products that I'm going to sell to everybody in the world. I'd like some insurance, please. I wonder what that looks like. I'm sure it's a hefty bill. So.
Yeah, I'm sure that they're super conservative about having the packs not explode themselves in people's hands. If the downside of that is a bunch of people think the packs are irretrievably dead, the upside of that is maybe they're not, and you can score a bunch of them on eBay.
Well, except now that we've spread the word, right? So
I'm not quite sure how to help you with that.
Buy them quick before the Hackaday effect kicks in.
Exactly. My next pick was from Thomas, and Thomas had a Muirhead K570B, which is a very peculiar looking machine, and it turns out it's a fax machine for sending wire photos. So it's a very high quality fax. Not well known on this side of the Atlantic, but Muirhead was a early telecom pioneer in Britain, and there's a company called Muirhead, just like there's a company called Bell Telephone, right? And so it's obviously not a piece of consumer equipment, the phone jacks are actually banana plugs. And so you can hook 2 phone wires up to it or 4 phone wires up to it using the banana jacks. The thing looks like something out of a bad science fiction movie, right? It's got a meter and, of course, the drum for moving the pictures and all that. But I'm always really interested in this. This one's actually only back to 1983, which by my standards is not that old, although I'm sure many of you would disagree with me. The fact is, the faxes have been available since the 1900s, early 1900s. So it kind of is back to the beer brewing thing, right? How did you do all those things? And I'll throw a link into the notes. I didn't do it, but we actually just earlier in the week did a piece about how they managed to send newswire photos back in, what was it, 1923, I think. Yeah. And so how do you digitize things in 1923? Well, it's actually a really interesting story. This one's a little more modern, but we take that so for granted now that Panda falls down in Beijing and you can watch it on YouTube in 30 minutes, right? and we're very not impressed by that anymore. But gosh, in the 1920s, the idea that something could happen and in the morning newspaper there's a picture of it, even though it happened all the way around the world, was really a miracle. And I think we've kind of lost that. Kind of like airplanes, right? You see an airplane flying overhead, you don't really marvel at it. But I think there was a time when you looked up and went, wow, that's amazing. And now it's just everyday life, right? So I love seeing these kind of tear downs. I mean, it's kind of before surface mount. So it's kind of the traditional looking pieces and parts. Mechanically, it's beautiful. I mean, just looks like a work of art mechanically. And I think it's interesting. I don't think he had any real good way to test it because you'd really kind of need 2 of them. I don't know that it actually did a standard. I don't think it was a standard, like a G2 or something. I have a feeling it's just whatever it did. So without 2 of them, I don't know that we would have much success actually making it run. But beautiful teardown. If you ever want, I did the link at the end too. If you ever really want to see a story about that era of fax machines, we did the piece about FedEx, where FedEx invested bazillions of dollars in having these custom, beautiful fax machines put in all their offices on the theory that, you could go into the FedEx office and say, I need this to be in California in an hour, and they would fax it to the other FedEx office and they would drive around and deliver it. And of course, they managed to roll that out right about the time that consumer fax machines dropped under, $150 or whatever. So of course, that went over extremely poorly. That tech had been around forever, but was kind of a niche, highly commercial, very expensive thing. And just suddenly overnight, it became a consumer item, disposable. And then again, overnight became almost pointless unless you're a doctor's office, of course. So
it's a beautiful machine. If you look at the teardown, it's like got, this drum. It basically scanned a light that went brighter and dimmer with a lens across it, but it runs along this long worm gear, and the one thing spins as the other thing spins. It's all synchronized. It's a lovely piece of like old school engineering. I'm sure you could reverse engineer the signals that you need to send images to this thing. I think that would be a hella cool project.
Oh, I'm sure you could, but the question is do you really want to do that so you can send a picture that you could just? I have a feeling he didn't want to put that much effort into it. I'm sure it's feasible, but it's not the same as just having another one. That came up I think it was the comments for this one, or maybe it was the comments for the other one about people talking about how ridiculous it is now that the medical people in the United States still want faxes, right? Oh, no, you can't email that, but you can fax it. So is that true in other parts of the world? How is it in Germany? Can you email your doctor, or do you have to send faxes everywhere?
I don't think we have faxes anymore.
I have to dig up how to fax something every time I got to send anything to a doctor's office. It's crazy.
Well, bringing up the rear for me, Nathan Matthias, Juicebox rescue freeing tethered EV chargers from corporate overlords. This is the story of Juicebox and the JuiceNet. I didn't know about this. It actually was a really neat project. It started up as kind of a hacker project that got kickstarted to make a set of do-it-yourself, build-it-yourself, actually, electric car chargers, and then group them together in a network so that you could lend yours out to other people. They could charge up there and you could get some money back on your account for letting someone else use your charger. So it's kind of a distributed DIY electric car charging infrastructure. And I think that's really cool. So that's the Juicebox and the JuiceNet. But then it got bought up by Enel, which is a large Italian, it may be the large Italian energy company, or at least it was by their foreign branch, Enel X, and they bought it up and started running it and then decided they weren't going to work in the American market after all and shut JuiceNet down, which meant that all these machines, your distributed network of electronic wall boxes is useless if the distributed network goes away. And so the question was, what are you going to do? Enter a bunch of hackers in this marvelous story summarized by Nathan. They both worked on a man in the middle for JuiceNet so that they could keep the machines running. And then a second project called Open EVSE developed replacement boards for the boxes. So you could actually just kind of do a brain transplant and keep it running. Nathan is a professor at Cornell and has a project here, is also founder of the Cat Lab, which is Citizens and Tech. And it's interesting to read his write-up of this because he's very much an academic, but what he's really doing and what this whole lab is doing is really just our kind of hacking. And so it's a kind of fun to see this written up from a more academic, less, hey, let's just open this thing up and see what we can do perspective. It's a good read to see what our world looks like reflected in the mirror of the ivory tower. Kind of fun. But at the end of the day, they're on the same team as we are, which is reverse engineering gear to make sure it keeps working even when its cloud services get bought up by a company that doesn't care about them anymore. And I think that is a really worthwhile goal. And I'm stoked to read the story of the juice box here. And I hope everybody's juice boxes keep on running.
It's really interesting. I mean, we're certainly seeing a trend there where companies have figured out, hey, why should I get your money once and then have to keep innovating to get more money? How about I just give you one thing and then you just give me money continuously for it, right? So, certainly from a business standpoint, that makes sense. But I'm always surprised we don't see more market force choice there. So, I'm thinking if I were an entrepreneur, which I'm decidedly not, but if I were, and I said, what was the piece we did a couple of years ago about the motorcycle airbag where you had to keep paying a fee for it to work, right? I would say, well, people don't like that, so therefore I'm going to come out with a competing product that you don't have to do that, right? You pay, and maybe it'll cost more, but I'll sell it by saying, yeah, but over a year it pays back, right? Now that's not a fair example because that particular product, you had the option of paying more and not paying the subscription. But my point still stands, right? If I saw something like that, I would think, hey, maybe I should do that. I can't help but wonder, though, if consumers are going to eventually get more savvy. We've seen that before, right? I mean, when, say, radio came out, people were more susceptible to scams over the radio. And then when TV came out, and, people do get more savvy about technology as it becomes more commonplace. I wonder if we're ever going to see a push where normal people will say, no, I won't buy that because it depends on your hinky network and I don't trust you to run it, right? Or conversely, if we would see something rise up that says, okay, they've paid us to keep this network running even if they go under, it's like an escrow for the network or something. I don't know. I don't know if that's really ever going to happen or not, but you would think the market forces, if people were educated enough, would push to that direction.
I agree that we are starting to see kind of normies wake up to this a little bit, and it's nice to see. Nathan's take on this, actually, he says he's worked at a bunch of hardware startups, and so he understands how this was for them. When you've started the product, you're like, oh, we can push over the air updates, we'll keep it always fresh, it'll keep everyone running, and they just don't realize that running this network for the next 10 years is going to be a cost that they aren't recouping money from. And I think a lot of these services did start off kind of naively rather than with malice. They're like, oh yeah, we'll provide you the service for life, because we want to keep our product running forever. And then they're like, oh, running these servers costs money. And quote, what seemed like a moneymaker starts to feel like a ball and chain for companies. They always have to keep supporting it and they always have to keep pushing out upgrades and running the server infrastructure. If they're not taking in more money, of course they want to close the server infrastructure down. Like you say, it's something that the consumer should wake up to. But if you think it's hard for the people who have the books, who are running the company to see this dead end future, it's even harder for people who, think the company is Google and is going to keep the product running forever.
As if Google does that, right?
The Nest had a lifetime warranty.
Yeah.
Turns out it was the product's lifetime and not yours.
Yeah, I was going to say it was this guy in Peoria. I don't know.
Exactly.
The worst example of that I've ever seen was here in the United States back when there was the free dial-up internet craze, right? Like Net Zero and that sort of thing. Kmart, the retailer of all people, had their blue light service. So you could get free internet from Kmart, and they would put a little ad on the screen. Of course, that costs a small fortune. And then in 6 months, they were complaining, well, people aren't buying stuff from Kmart. Yeah, well, no, of course not. They got on the internet and they're buying stuff probably from Amazon, or what I suspect a lot was going on is they were surfing for things you don't want to think about Kmart, because I think it was pretty wide open. So I think in the boardroom somewhere, they were like, well, yeah, we'll give people the internet, and that way they'll be able to just get up in the morning and start immediately buying from Kmart and continue buying all day long until they go to bed. And of course, that really probably wasn't a very realistic standpoint. I was talking about network escrow or something. Actually, the thing to do if somebody were entrepreneurial, if I were one of these cloud companies like Amazon or Google, is to say, I'm going to have IoT net as a service, and I'm going to help educate the public that if you buy something that uses IoT net and the company goes under, it won't matter, right? Because we maintain the network. And as long as they follow the certain design rules, it won't matter, right? That would be an interesting service and would attract people to use your offering, because you could then hawk it to the public and say, oh, yes, it's safe. But I think we're going to have a lot more public awareness of why that's a problem before something like that would be feasible.
Yeah, I've heard the idea floated around that when a company bails on a service like this, they should be required to open source the server infrastructure so people could, work on their own. I kind of like that solution, but honestly, that's a solution just for our crowd. Like, that will make Tom Nardi super happy, but not my grandma.
Well, the other thing is, business-wise, that could be tough because probably my server uses stuff I don't have the license to open source.
Fair enough. Yeah, sure.
If I use, I don't know, MATLAB or something in my back end, well, I can't open source MATLAB, so
Yeah, of
you
course.
could only do so much. My last pick is David. The article is RP 2040 Assembly Language Mix and Match. I got to tell you, Elliot, there's a lot of pleasures to writing for Hackaday, interacting with the readers, meeting them at SuperCon. But one of the things I really do enjoy is sometimes you can find like a relatively obscure YouTube channel or blog and give it some exposure. So I felt like this kind of fell into that category. David's got a really interesting series of videos, there's quite a few of them, about building up a keypad using the RP 2040. And he's probably got some other stuff too, but that was the series I noticed. But he's got it's an impressive number of subscribers for a small channel, but it's not the 100 million subscribers that you see some people with. And the videos had relatively low counts. But it was really good content. And in this particular installment of the video series, he's taken this keyboard, he's already written the scanning code for it, but he was stymied because he needed to read 1 byte. And the RP 2040's got the word-oriented stuff, so you have to grab a word and fish the byte out of it. Now, I'll be honest with you, that's not that hard to do. But on the other hand, in assembly language, it's trivially easy to say, give me that byte, and it pulls it out. So that's what he wanted to do. And it makes a nice example of mixing assembly code in with your C code, which we've talked about that also on several different occasions for different architectures. So it's one of those things, you don't need it every day, but when you do need it, you really need it. I'm not sure David really needed it in this case, but again, I think it made a good example. So when you do need it, it's something easy to digest, easy to figure out, and kind of use it as a basis to go on your own stuff. But honestly, the real take here is this whole series. If you're really trying to get into using those kind of things at that level, I think it's a nice series, and it kind of makes a very logical progression through until you're in these later parts where you're even writing assembly language. So it's pretty comprehensive.
Yeah, I love this guy's videos. When I needed to learn about the RP 2040's programmable IOs, the PIO units on there, I watched his series, and it was actually really good. And Dan Jovic comes in the comments and mentions that, and I'm like, yeah, word. I learned half of what I know about PIOs from this guy's videos. I held my tongue and totally didn't write in the comments in response to Greg A, who says, well, this is easy. Greg's point is this is just a pointer to a character pointer, and if you are good enough with C and especially pointers in C, you should be able to figure this out. And I always have to look where the parentheses go when I'm doing a pointer to another typed pointer, but whatever. I know the concept. So you didn't need to do it in assembly language. Although that whole pointer to character pointer thing, it's a little bit unreadable. And David's solution, which was to have a function that he wrote called get byte and write byte, is so much more readable in the flow of your program. And if you inline it, it's going to be the same thing either way. So at that point, I was thinking, it's potato, potato. If you're going to write a wrapper function for it to make your code more readable, it doesn't matter if you're writing the wrapper function in C or assembly language, because when the compiler does it, it runs down to the same machine code anyway.
Yes.
And that had me think about, why would you do one versus the other? And the answer is just because you're more familiar with one, or it's more readable to you, or it's more maintainable if you're sharing the code with other people, or blah, blah, blah. I think it's really cool to mix languages because different languages have different strengths, and it's easier and or more readable to express some ideas in one computer language than it is in another. If you know multiple languages, I think you should feel free to express yourself in them. On the other hand, if you don't, or if your readers don't, you might be leading them into confusion by doing this. I think it's cool to be able to switch these levels, but again, that's all user dependent. So I'm not going to say there's a right way or a wrong way.
In all fairness, I mentioned the same thing, right? Is this may not be the best example of why you want to do this. And even Greg A says that at the end of his comment. He says, but on the other hand, it is good to show people that inline assem isn't that hard, right? So
that's the point, right?
Yeah, I think some of it was a little put on that, it's so hard to get a single byte out of the word. There's a dozen ways that could be skinned. And as far as the wrapper functions, like you say, that could have been done in Turbo Pascal. Well, no, probably not a code generator but it could have been done in anything. That's not really material. But I do think this is one of those things that does have some reason you might want to use it. And then the question is how do you use it? And this answers that very well. I was surprised he didn't redo his keyboard scanning in the assembly language, simply because that would allow you to really go to a potentially higher scan rate, because you could really optimize that. But maybe not. I don't know. The compiler may be so good that it really wouldn't be a lot of advantage to that. You'd have to try it to know for sure.
And that's actually the real good point that comes out of Greg A's comments there. He actually says, so as to be the change I want to see in the world, I'm going to tell you, use GCC minus S, right, to see the decompiled output. And, that gives you the kind of assembly level insight into what your C code is doing, and is actually a totally useful thing to do if you're trying to speed optimize, like a tight loop like you were talking about.
Yep.
I love multiple languages, but I can see how it would drive people crazy. Like if you don't know assembly and you walk up to this and you're like, what are all these LDAs? What does this even mean?
The leisurely disclosure agreement. That's it.
My first quick hack comes from Upir, Homebrew Tire Pressure Monitoring System. This is a crazy long walkthrough of an Arduino system he made, where he starts with a bunch of purchased from Alibaba BLE tire pressure monitoring devices and figuring out the protocol they speak, hooking it up to an OLED, testing them by making a little syringe pressure chamber. It's absolutely fantastic. The video is long, but ends up being kind of a beginning to end tutorial of how to make a microcontroller project that's got a screen and nice graphics and actually does something useful. And in the end looks, almost professional enough you could have bought it. So really cool project. And it made me think how useful these like cheap tire pressure sensors could be anytime you want to do like temperature pressure sensing. I wonder. Next up, Iron Fuse troubled USB device. This tool can help. This is the mother of all USB testers. It's got 12 different connectors around a circle, and you can plug the USB cable in there, and it's got probe points so you can see which lines they have in them, if they're working, if they're connected. You could just test it all out. I know you've seen those little credit card shaped ones where you can plug a USB-C on either side and it lights up things. This is that, but with test points and for every type of USB out there all at once. And last up, Xenon John Dingley, Butter Melta stops rock solid butter from tearing your toast, is just a funny little 3D print. It holds those little foil wrapped butter packages and it holds it against the side of your teacup to warm it up so that you're not stuck spreading cold butter on your cold English breakfast toast. It's just an absolutely fantastic 3D printing project. It's totally senseless. It's really cute. It's whimsical, and it's got a fantastic video attached to it. Give it a watch. It's just fun.
Hackaday solving your first world problems every day.
Butter melta.
Well, my three picks are pretty esoteric this week. Asianometry, a very interesting channel, had the most fascinating video on an old operating system. And if you'd asked me before this, if I name an old operating system, would you at least be able to say you've heard of it? I would have said, oh, of course, right? And I'd never heard of this one. It was the PIC operating system. And it had this insane history of, starting out as a military project and they didn't protect it. So the guy just started his own company and it got used in a bunch of different computers. And then, but it was very strange. Everything was everything was a database and it looked kind of suspiciously like an IBM ISAM database, if you remember those. But apparently, and I didn't know this, there's still a few pockets of people clutching to this maniacally because they've got some system that uses it. And there's still people who want the PIC OS. So that's interesting. A little more modern, there's the Shader Academy, which is actually in your browser, has little exercises where you try to match particular output by writing GPU code for web GPU. And it kind of explains what you should do and it'll show you the solution if you want. But it also has a nice diff where you say, okay, you're supposed to be drawing this Mandelbrot set, but I can detect that these 28 pixels are not what they were supposed to be. So you screwed something up and I'll show you where. And I'll tell you how many, you got 80% of it, you got 90% of it. I was surprised they didn't call themselves the Shady School, but I guess in retrospect, maybe that doesn't sound as good as Shader Academy. And then finally, Zaffer Yiddiz, I hope I pronounced that correctly, has Dead Bug Timer Relay Needs No PCB. So you know how you're watching on TV and you see a guy jump a bunch of buses on a motorcycle and you think, that's cool. Not that I want to do that, but it's still cool, right? And I think that's the same thing here. He essentially wires up a timer relay, not very hard to do, but he doesn't use a PCB. It's all this kind of dead bug construction. In real life, you would never want to do that. It would not be super robust, and over time, it's undoubtedly going to come apart. But it was a very neat job, and certainly there are times when all of us have done something dead bug, either for something expedient or a prototype or a repair. So I liked his bending of the chip leads to kind of make terminal posts, and there's a lot of cute little ideas in there. Again, don't try this at home unless you're just playing around. I would not want to deploy this in my car or in some sort of actual use that I wasn't going to pick it back up in an hour, a couple of hours, but still a nice video.
I couldn't believe the comments in that PIC operating system one, by the way.
It was a lot of people, yeah.
Some of the original authors of PIC show up in there. It's crazy. I'd never even heard of it.
That was what got me, is if you'd said we talked about, VM or something on IBM, or you'd say, well, yeah, sure, of course, there was a lot of people doing that. Everybody knows what that was. I'd never heard of this, and I have not run into anybody in my normal life that said, oh, yeah, I knew about that, so.
But there are 20 of them in the Hackaday comments.
Yes, and not only that, some people seem like they were still using it, right? That's what was really wild, so.
All right, it's time for our can't miss articles. These are long form pieces written by our fantastic Hackaday writing staff. This week I'm picking Tom Nardi's The Browser Wasn't Enough. Google Wants to Control All Your Software. And this is a reaction to the news that came out earlier this week that Google was going to crack down on side-loading Android applications. First off, what is sideloading? Sideloading is when you get an application that you want to install on your phone and you install it on your phone, like without even going through Google Play Store, like the nerve. How could you? To Google's credit, they've been fairly lax with Android and allowing people to, quote, sideload, that is, decide which software they want to load on their own phone and pick it up from whatever source they get it. Until this proposition where they're saying, yeah, we can't have people just loading their own software on here. They have to load it from trusted sources. And so the idea is that Google is going to vet verified developers, and even side-loaded software is going to have to come from a verified developer to be installed on your phone. Of course, this rubs a whole bunch of people the wrong way. The real open question is what's going to happen with all of the open source software out there for the Android ecosystem. I don't know if you, our listeners, know about the F-Droid repository, but it is like a shadow Google Play Store, but it's full of open source software. And some of the best applications for like OpenStreetMap, and for us here in Germany, one of the best public transit apps is on F-Droid. Canine Mail, a great mail client, is on F-Droid. Ton of the software that I use on my phone comes from this source, and without sideloading, none of this would work. And so is Google going to go through every piece of software on the F-Droid repository and make sure that everybody there is a verified developer? Or is this just going to put a big fork in the use of open source software on the Android platform? Who knows is the short answer. Tom brings up, all the kind of sinister things that could happen if Google decides that it doesn't want this piece of software to be sideloadable or that. I think that's also a worry, but I think more so is just kind of the effect that having people who want to write software for the Android platform have to jump through this hoop of becoming a verified developer to do so. And that's the part that really chaffs me, is that if I wanted to write an app, this would stop me from doing it. I would be like, I kind of maybe feel like writing a phone app and then trying to load it on my own phone. And then, oh, wait, I have to go through the whole verified developer rigmarole. Maybe I won't do it. And that kind of worries me that other people will feel that way. There's been a bunch of pushback on this so far, and some murmurings about them going to carve out an exception for academia students and for installing software on your own personal phone. So maybe we'll get that, maybe we won't. Given that Google already has kind of a de facto monopoly through the Play Store on what apps normies install on their phones anyway, I think the whole thing's a little bit galling that they're going to then take on sideloading. If I were the US FTC, I think there would be an anti-monopoly complaint here that could be lodged.
Well, not to mention the EU, right? So
yeah, they have actually taken the Play Store and Apple's store to task here in the EU. Oh, I wonder if this is a reaction to that. That's interesting.
yeah, I don't know. My guess is, I could take either side of this. I mean, me personally, yeah, I hate this. And I load stuff on my phone all the time that I know Google would not allow me to load, including stuff I write. Like, for example, this week, I had a post on Hackaday where I wrote some software. Now, I actually used to have a couple of things on the Play Store, so I may be a registered developer somewhere, but like I didn't sign these apps. I don't know. I may have been able to, but I didn't. The thing that gets me, though, is I could argue, if I wanted to argue the other side as well, people are going to blame us if, you put something on the phone that steals all their personal information and empties your bank account. But I figure if you want to do that, have something on the developer mode that says do not check verification, validation. I understand, bring up a box and goes, ooh, that's really a bad idea. You realize we won't be responsible for anything that happens no matter what. And you go, yes, I understand. And we're done, right? At that point, I would be okay with that. I realize you probably don't want, who was it you used as an example earlier, your grandmother loading random stuff off the internet onto her phone. Got it. But that doesn't really apply to me and you, right? I think we're big boys if we want to put something we found on the internet on the phone. I mean, even the stuff I'm writing lately, it goes through 9 steps of, I don't know where that came from. Do you want me to scan it? And you can say no, but if you do, it goes, ooh, that's so bad, such a bad idea. So there's 9 buttons I have to push every time I want to load a new APK for this because it keeps saying, well, let me scan it. Okay, well, it's okay. Are you sure you want to install it? I'm okay with that to an extent, but I get the fact that maybe you don't want everybody loading my random apps without some sort of positive acknowledgement that you're doing something dangerous.
But there already is a pop-up when you sideload things. It already asks you if you want to allow from this source, and you have to say yes. So
Totally
we're
agree.
already in that world, and it's
Well, don't get me wrong. My original statement
yeah,
is I'm not
yeah.
for this. I mean, but I could see if you said, well, but you might have sideloaded something 5 years ago and you forgot about it, and now you don't remember that you agreed to that. So I get it. Like right, but even right now, like I said, loading my own stuff, it's 9 steps of having to go, yes, 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 you can scan it. Okay, it looks okay to you.
Yeah.
Yes, yes. It's like a bad Monty Python sketch, right? Size 5. And I'm okay with that. I think that's sufficient. I don't think you need to say, no, no, I'm locking you up. You can't possibly do anything because you're obviously too stupid to make a decision. If you want to force it to make sure I positively made that decision, sure, I'm okay with that.
On one hand, we shouldn't be too hard on them here because maybe there is a security benefit here. Like if they know who you are and your program goes rogue, they can send the Google's team of jackbooted thugs to come beat you up and get you to not write bad software again or something. I No, I don't think there's any reasonable world in which, like, I'm not sure knowing who wrote the bad software makes the software any better or stops them from assuming another pseudonym and passing their bad software off again. Like, I don't think this is going to stop any malware writers from becoming verified developers and then writing their malware. And that's the part that kind of galls me. I did a phone app once and I wanted it to be cross-platform, so I had to get it to run on iOS as well. And there you actually have to become a certified developer already, and you have to
Yes.
pay them like, forgotten whether it was $50 a year or $100 a year to get a signing key so that you can put it on a phone. Or, so that in this case I could send it to a friend of mine so he could put it on his phone. But man, that scam's already in the Apple world, and it may just be that Google's trying to catch up on that. I don't know. Last thing I want to say about this, if you read their blog post on it, they're like grasping at straws to find any security benefit here. And my favorite quote is the following. In early discussions about this initiative, we've been encouraged by the supportive initial feedback we've received. In Brazil, the Brazilian Federation of Banks, FEBRABAN, sees it as a significant advancement in protecting users and encouraging accountability. This extends to other governments, India's Ministry of Communications. This is what they've got. Thailand's Ministry of Digital Economy sees this as a positive and proactive measure. Like, they reached out to the security community and they got the Brazilian Federation of Banks and Indonesia's Ministry of Communications to sign on to this. I'm just saying.
I don't know how to answer that.
So Tom's hopeful in this that they'll get enough pushback that they'll walk it back. And I don't know if I'm hopeful, but I think that's probably the best outcome. So if you have any leverage with Google, push them on this. Tell them it's a dumb idea and it's going to have a chilling effect on the Android open source and otherwise fun software ecosystem that has made having a phone as much fun as it is.
Okay, well, my pick this week is from Dan Maloney. It's Where There Is No Down, Measuring Liquid Levels in Space. Big science fiction fan and occasional science fiction writer, I'm always amazed at how many times you see, like on a bad TV show where they're in space and the guy's in shock, so they put a blanket over him. And it's like, well, but heat doesn't necessarily rise in microgravity. And you have the same problem here as if you're in a zero gravity or microgravity environment. How do you know how much fuel's in a tank, for example, which is pretty important to know? You can't assume, well, okay, the top of the liquid's here. Well, why would that could be the bottom of the liquid or the side of the liquid or anything else. It's one of those things you don't think about until you've had to design something where there's no gravity. Dan does a great job of kind of pulling all that apart. And he talks about how some of the rockets do flow accounting. So they say, well, we don't know how much fuel we have, but we know how much we started with and we know how much we burned it. He talks about, ullage, which is the technical term for how much is missing out of the top of a tank. In this case, not necessarily the top, right? But how much is missing out of the total volume of the tank. And in fact, if you've ever seen those nice little the air-cooled engines on the Saturn, some of the Saturn rockets, those motors were strictly to make sure all the fuel got down to the bottom of the tank instead of floating up near the top of the tank. It's really interesting. And then he talks about his words. I would have used a slightly different set of words as monitoring pee on a space station may be important. But keeping track of propellants is a matter of life and death. So, but he talks about PUGs, the propellant utilization gauge subsystem from Apollo. And, you don't think about that, right? There's all these things where you think about the navigation and you got to figure out how high you are over the moon. But, if you ever played Lunar Lander on a old teletype, running out of fuel is not a good way to land the lander. And I think that goes here too. So it's pretty interesting deep dive. I'm not going to go into every little detail of it. But yeah, I think, Dan did a great job of covering it. I found it really interesting. I learned a few things. The 3 waste and hygiene compartments, if you're wondering why that all came up earlier, is mentioned in there as well. For the urine processing assembly, that would have been more my choice of words, I think. So anyway. But yeah, it's a great post. You should check it out.
Yeah, like you said, it's just one of those problems that you don't think about because you live here on Earth where there's all sorts of gravity pulling liquid down, right? So you said it perfectly, like you don't know where the top is because there is no top in space. It's all just around. The thing I took out of it was the motors that you fire to get the fuel back down at the bottom of the tank inertially. Like, that's really a great idea. And I'm sure that whoever thought of that solution was like, well, we don't have gravity. What do we have? Well, we've got inertia. Okay, let's fire off a little rocket motor to get the fuel where it needs to be in the big rocket motor. Pretty cool. I love the idea that you could line the inside of a tank with a bunch of conductive plates and then use capacitance to sense how much liquid there is inside the tank, no matter where it is. So it's kind of like a full volume of the tank volume detector. Anyway, both a ton of cool engineering going on here and eye-opening into a problem that you didn't know you have until you're in no gravity. Yeah, I thought that was a stellar article. Well, that wraps it up for this week's Hackaday podcast. Thanks very much for listening. To find all the links, head on over to hackaday.com/podcast. And if you want to suggest a story, shoot us a line, tips@hackaday.com. And until next week,
keep those hacks coming. No, that's okay. I'm not even going to do that one. Oh, I see it.
For as much...
Okay, I think we're done.
Kind of do a brain plant. Have to look up that acronym. Damn it. These are fantastic pieces written by our own marvelous Hackaday writing staff. What are my people?
Well, that turned out to be surprisingly long.
Yeah, exactly. But I said fantastic earlier, so I choked.
Off the record here,
I think we're all set.